Today we'll be solving the problem nice pairs, which is a simple problem. The problem statement here says that we are given with a string s which is of length n and it contains only numerical characters, and we have to find the number of nice pairs. Now the definition of nice pairs is given to us. It means that we will have to form all the pairs that are possible from this particular string, and then we will have to check this condition for each of the pairs. And this I and j that you see, it is the indexes. So when you put each of the element of the string in the form of an array, and for array for a string itself, you know that it has indexes, right? From 0 to n minus 1 indexes. So that is what it means here. And also it means that I is less than j, right? So it means that a single element cannot form a pair with itself. So let us take an example and understand how this problem is getting solved, or means how this expression is being used. So let us take s equals to 4, 5, 6, and here n will be equals to 3 because there are 3 elements in this string, and let's give them their indexes as well. So here the indexes are used from 1 to n, right? So we will also use them from 1 to n instead of from 0. So this is 1, this is 2, and this is 3. Okay, so these are the indexes. Now let us do a dry run and see how this this expression is working. So let's take I and j. So first we will take I equals to 1, right? And j values can be 2 and 3, right? It cannot be 1 because 1 comma 1 means an element cannot make a pair with itself. So these are the two pairs possible with the first element. So the pair that will be formed will be 4 comma 5 and 4 comma 6. Now if we put this in this expression, then j minus I will come out to be 2 minus 1 for this particular expression. It will be 2 minus 1, and s of j minus s of I means we have to see the elements. So s of j is 5, and this is s of j, this is s of I. So s of j is 5, s of I is 4. So we are getting here 2 minus 1 and 5 minus 4 is also 1. So it means that it is forming a nice pair, right? Now for the second pair, similarly you can do the same thing. So 3 minus 1 is 2, and mod of 6 minus 4 will also give you 2. So this is also forming a nice pair. Now we will come to the second index. So when we will make I equals to 2, then we can take j equals to 3 because I is less than j here, as you can see. Now here s of 2 is 5 and this will be 6. So again it will be forming a nice pair, as you must have understood how we are using this expression to find out the nice pairs. So you must have understood the flow. And 6 minus 5, so this is giving us 1. 3 minus 2 is 1, so this is also forming a nice pair. So in this particular example, 3 nice pairs are being formed. So this is how you have to think about the problem. Now before jumping to any conclusions that how we are going to solve this problem or what we should use to solve this problem, first let us take a look at the input, output and constraints, and then after this problem is going to become a lot simpler for us. So the first line of input is the test cases. Okay, this part you can figure out yourself, the input format. Now I am concerned with this particular line here. It says that what are the characters that can be there in the string. So it says here that the string will only have numeric characters from 0 to 9. Alright, and we already know that the string had only numeric characters, or only numbers would be there in the string. So like if you're writing 1, 2, 3, 4 or whatever is the string, you cannot count it as 12 or 34, right? So this will be counted as a single digit. So 1, 2, 3, 4 would mean single digits, and single digits are only from 1 to 9 including 0. So it is specified here that the string will have integers from 0 to 9. What does that mean and how does it help us? How does it help us is, that now if we pick up any two values out of the array and we try to find out the difference, because what is our expression? Our expression is j minus I should be equal to s of j minus s of I, right? This is our expression. S of j and s of I means any two values out of this particular string, and note that these values will be from 0 to 9. So if we pick up the extreme values out of this string, which is 0 and which is 9, and it will somehow form a pair. So if we pick these values up, then we will get the difference as 9. So 9 can be the maximum difference that can be there when we are performing this particular expression, s of j minus s of I. So when we are forming the pairs and we are taking the difference of that pairs, and mod means that we will always be taking the positive difference. So it means that the maximum difference that we can get is always 9 and not more than that, because of the fact that there will only be 0 to 9 characters, 0 to 9 numbers in the string. So you can just randomly choose any two values from here and check 7 and 2. So 7 and 2, 7 minus 2 will give you 5. Let's check for 9 and 0. So already 9 minus 1 will give you 8. So it will always be less than 9. Now how does this matter? It matters because if this value is 9 at max, then j minus I will also have to be 9 at max in order to match this particular value. So if j minus I is greater than 9 for any case, then it's useless, right? Because it will anyway never match this s of j minus s of I. It will never be able to be equal to s of j minus s of I. So if j minus I is greater than 9, then it can never be equal to s of j minus s of I. This is what I mean to say. So what we can do, that we have to form pairs. So first of all, let us understand how we are forming the pairs. So we can simply form the pairs by using two loops, right? So first loop will be from I equals to 1 to I equals to n minus from I equals to n, right? So here I have used 0 based indexing. That is why we can also use like 0 to n minus 1. But if we are using indexing from 1, then the first loop will be from 1 to n, right? Now what about the second loop? The second loop, ideally, if you are forming all the pairs that are there, so ideally the second loop should run from I plus 1 up to n, right? This is how the second loop should be running. But not here, because what we can do here is that we only need actually till 9, means whenever we are getting j minus I equals to 9, we only need values till that place. After that, the values are useless to us. Okay, so what we can do, that instead of just making the loop till n, we can do minimum of n comma I plus 9. Now let's understand why this j, that is the second loop, should be till n, minimum of n comma I plus 9. Because we want that j minus I should not be more than 9, because in that case we have already seen that whatever be the value of s of j minus s of I, it will never be more than 9. So means these values can never form nice pairs. So what is the point of even checking them? And you can see that let's take the extreme values and check what does this mean. So here if I is suppose equals to 1, and now you're considering j, so your j will be equals to your j will start from 2 and it will go till I plus 9, that is it will go up till 10. So if you will do 10 minus 1, you will get 9. But now if suppose your j was, for example, 11, if your j was 11 and if you did 11 minus 1, then 11 minus 1 will give you 10, right? 11, and if 11 minus 1 is giving you 10, that is j minus I is giving you 10, and if it is giving you 10, then it will never match this value and it will not form a nice pair. So I hope that you have understood why we are running the loop till I plus 9. Now why do we need this minimum of n comma I plus 9? Because it may also happen that I plus 9 values might not exist. For example, if you see in this particular example that we have taken, so if suppose I is equals to 6 and if you are doing 6 plus 9, so 9 plus 6 will give you 15, but you can see that there are no values up till 15 index. So in that case, this minimum of n comma I plus 9 will be useful, because then in that case this loop will only run till n and it will not go for any kind of values which do not exist at all. So we will run these two loops and it will help us form the nice pairs. Means it will help us see whether the nice pairs, how many nice pairs are there. And after means this is the first loop that will be done, and inside this first loop this will be the second loop, and then we will just simply check the condition that if j minus I is equal to s of j minus s of I, and for this you will take the absolute value because we need the positive difference of this value. So you're taking the absolute value. If this is true, then we will take a variable which will originally be 0 and then we will just increment that variable. So this is going to give you your answer. This you can run, you can do the dry run for a simple problem and you can see for yourself if it is working or not. So I hope that you have understood the solution and why we are using this expression. So I'm sure that some people will think of a very complex solution for this problem, but no, you can just directly use two loops here and solve this problem, and it will give you time complexity as order of 9 into n. So this will be a linear time complexity. It will not be n square here. Remember, it will not be n square because you are running the loop from I plus 1 up to I plus 9, or if I plus 9 values are not there, then n. So you are not running the loop for each and every, like for each and every iteration, you are not running the loop for all the values. So that is why the time complexity will be 9 into n. So this is giving you the linear time complexity. So this solution will work. So guys, the code will be in C++. Here first few lines are just the input, and I don't think that there is anything else left to explain in the code. It's just that you need to see the syntax and how exactly are we using it, exactly are we forming the loops in order to test for the nice pairs condition. So first of all, I have just initialized this answer variable as 0 because here we will count how many nice pairs are there, and then this is also the input. This is the input for the string. So s is defined as string here, and now after we have all the values, we'll run the first loop. So first loop will run from 0 to less than n. 0 because this is a string, right, and indexing in a string starts from 0. So that is why from 0 to less than n. Now the second loop, that is the one which is inside this first loop, will run from I plus 1. So this is the same as we discussed in our solution, our discussion. So it will run from I plus 1 to less than equal to minimum of I plus 9 comma n minus 1. So if you remove this equal to here, then you can make it from I plus 10 to n. But since here I am using equal to, so it will run from I plus 9 to comma n minus 1, minimum of any of these two, and j plus plus. Then we will just simply check the condition, that is j minus I, if it is equal absolute of s of j minus s of I. This is a nice pair condition, and then we will just, if this condition is true, we will just increment the answer variable by 1. And at last, after coming out of these loops, we are just printing the answer variable, and that's it. That's our code. So I hope that you have understood the concept of this problem, how we are solving it, because the code is not exactly very important, but it is important that you understand the concept so that you are able to code this on your own. So if you have any doubts, then please post them in the comment section, and don't forget to like the video and subscribe to our channel.